All right, so in this one, we're going to look at parabolas with the horizontal axis that open up sideways, if you will. So obviously these are not functions, but we can still talk about them. And basically everything is reversed. So the vertex is still at the origin. That doesn't change for this section. Um, Instead of x squared equals 4py, we are switching the x and the y. So we have y squared equals 4px. Of course, when the x is squared, that's a function that we're used to working with. That opens up or down. So it makes sense if the y is the one that's squared, it's going to be opening either to the left or to the right. Um, Instead of the focus being 0p, of course, the focus is going to be p0. And then instead of y equals negative p for the directrix, we're going to have x equals negative p. And then if p is greater than 0, we open to the right. And this would make sense because this is the positive x side. So if p is positive, of course, it's going to open to the positive end. And then opposite if it's negative. So p is negative, it opens to the left. So and for me, if it's only the vertical ones, these would be, I don't want to say they're hard, but it does get a little bit confusing, keeping straight which one is the X and which one is the Y. So the focus part can help. Um, because obviously if the focus is um, if the P is in the X part, it's going to be on the X axis. If the P is in the Y part, it's going to be on the Y axis. And that tells you which way it's going to open, at least for now, while we're sitting on the vertex with being in the origin. That does make things a little bit easier. So let's look at an example here. We have 6x plus y squared equals 0. Find the focus directrix and sketch the graph. So first we need to put this in the form that we like, which is get the y squared by itself. So y squared equals negative 6x. This tells us that we're going to be opening to the left like this, because that's negative. Negative 6 is going to equal 4p, which tells us that p is negative 3 halves. So that tells us that the focus is negative 3 halves, comma 0, and then the directrix is x equals, and then we change the sign, 3 halves. And then we can sketch the graph, and we're going to sketch the graph the same way. I just put the vertex at the origin. We can, now on WebAssign, you don't have to put the focus on there, if I remember correctly, but you do have to graph the directrix, the parabola and the directrix. So you will be doing two things. So just sketch the line. And it's not a dotted line. Don't do a dotted line. I don't know why I do that, but um, just a graph a line like you probably did earlier. Maybe not. Maybe we skipped the linear function. I don't remember. But straight line, double arrows on the ends. So goes on forever. And then now we just need another point. We'll do 2 points since we're drawing this by hand. But using this now, can you get this side to be a perfect square? X is always negative. The domain is negative infinity to 0. So if we make this side 36, that would be a perfect square. So let's just make x be 6, negative 6. And then y is going to, so it'd be y squared equals 36. So y is plus or minus 6. And so we'll just kind of put this up here somewhere and look something like that. So literally you're just doing the same thing with the vertical ones, just everything is flipped. So no big deal, no big deal. All right, so let's talk about focal diameter. So all the focal diameter, we'll draw a picture here. Hopefully this will be relatively clear, but let's draw one, something like this. And this works with the vertical as well. So it doesn't just have to be the horizontal ones. But let's put our focus here. It doesn't really matter. It's wherever it is. It doesn't matter too much. But the ordered pair, of course, is P0. So that length would be P. Um, now this distance, and then of course the directrix. Let me draw a solid line. Maybe that's why. So there's a y-axis. Here's the directrix. Of course, so this distance, oops, this distance from the from the focus, whatever point that would be on the parabola, that distance is p. And then of course, from the directrix to the vertex, the horizontal distance would also be p. Um, and so we also know that from any point, so the definition of the parabola, from any point on the parabola, the distance, and of course this picture doesn't work exactly because I hand drew it, but the definition, the distance from the parabola, a point on the parabola to the directrix, that distance is the same as that distance. So this distance would be 2p. No, it doesn't look like it on the picture, but that's the thing about mathematicians. We don't have to make our pictures look to scale. Just we label it the way we want it to look, and that's the way it is. So the definition of the parabola, you can pick any point on here, the distance from here to the focus, and the distance from that same point to the directrix is equal. They're equidistant. So this is 2p, and we can pretty easily prove that from here to here is p, and then the directrix is an equal distance to the vertex. So that's 2p, and then likewise, going in this direction, that would also be 2p. So the focal diameter is, so the focal diameter is absolute value. I wish I would quit doing that. Can we? I don't know how to get rid of this. All right, absolute value of 4p. Okay, so it's basically just measuring this distance. So whatever point you're at, well, it's the distance at going through the focus. So from one side of the parabola to the other, going through the focus, that is the absolute value of 4p. Absolute value because we're talking about distance. So let's look at this example. Oops. Find the focus directrix and focal diameter. So we have y equals 1/2 x squared. Let's solve this. All right, we got it. Okay, got that fixed. All right, so we're going to solve this for x squared. So multiply both sides by 2, we get x squared equals 2y. And we know this is equal to 4py just based on our formula for the parabola. So this tells us that 2 equals 4p, which means that p equals 1/2. So our focus is 1/2 0. The directrix is not parentheses, but x equals negative 1/2. And so let's sketch the graph. Directrix negative 1/2. We'll put arrows here to indicate this is the y-axis. Vertex, and then x squared equals 2y. So if we let y equal 2, then x squared equals 4. So x is plus or minus 2. Right. We messed up. Let's go back. Sorry about that. Not that, not that. This is opening up. I was expecting this one to be horizontal, but x is squared, so this one opens up. So 0 1/2, and then y equals negative 1/2. See, this is the tricky part is just remembering which way you're doing this. So there's our directrix. There is our focus, and then we can let y equal 2, and then that means that x is plus or minus 2. So if y is 2, x squared equals 4, x is plus or minus 2. But again, that's just to help us with WebAssign. So you have to graph that. And then the focal diameter is absolute value for P. P is 1/2. So that will be absolute value of 2 or just 2. Okay. Hopefully that didn't throw us too far off. I just was expecting this to be horizontal and it wasn't horizontal. So my mistake. All right. Then the last thing, so we're just going to compare a few of these equations. And these are very easy to get when if we're just given the focus. So let's just do F1 here. We'll do F2, F3. So these are going to be four different ones. But P is 1/2. And this is on the y-axis. So these are all going to be opening up. So the P is 1/8. So we have x squared equals 4 times 1/8 y. So x squared equals 1/2 y. Or if you like, you solve it for y. We get y equals 2x squared. F2, P is 1/2. X squared equals 4 times 1/2 y. So x squared equals 2y, or if we solve for y, we get y equals 1/2 x squared. F3, P is 1. X squared equals 4py. So x squared equals 4y. And so we have y equals 1/4 x squared. And then the last one, P is 4. X squared equals 4 times 4y. X squared equals 16y. So we get y equals 1/16 x squared. Now, kind of went through that fast. That's nothing too involved there. Given the P, just plug it into the formula and there you go. But let's look at the graph of each of these. So we have the graph down here. And so what you can see is so these get wider as we go. So and we could tell this, we learned transformations. So if it's a bigger number here, makes the graph narrower. If it's a smaller number or getting closer to 0, it makes the graph wider. So we can see that. But we can also see the wider the graph gets, the bigger the distance the focus gets from the vertex. So that's kind of the idea there. But again, practice these a little bit. No difficult math here, like when you solve quadratic equations that can be a little bit more involved. These are very basic maths, just kind of memorizing a couple of formulas and you're good to go. So if you have any questions, let me know.